A uniform rectangular block of mass m and cross-section ABCD has AB is equal to CD is equal to 6 times A, and AD is equal to BC is equal to 2 times A. The point X is on AB such that AX is equal to A, and G is the center of ABCD. The block is placed with AB perpendicular to the straight edge of a rough horizontal table. AX is in contact with the table and XB overhangs the edge. See diagram. The block is released from rest in this position and it rotates without slipping about a horizontal axis through X. Find the moment of inertia of the block about the axis of rotation. So let's see. We will use this formula. The moment of inertia of a rectangular when the axis goes through the center of mass, this formula, and when the axis goes through some other point and its point is from distance d from center of mass, then to this axis the moment of inertia is this. So we have to add this value to the previous value. M is the mass and d is this distance. So we will use this formula. How? First we calculate this gx from Pythagoras. This is 3 times a minus a, so this is 2 times a, and half of 2 times a, it's a. So here is gx is equal to square root of 5 times a. It is here. And moment of inertia when the axis goes through G, it is here. This is one side squared plus the other side squared. It's 40 times a squared, and simplify by 4, we get this value. And now to x, it is we apply this formula. So inertia of g plus m times distance squared. It's 5 times a squared. It is here. And this is 15 over 3, 15 plus 10, 25 over 3 times m times a squared. For the instant when xg is horizontal, show that the angular acceleration of the block is 3 times square root of 5 times g over 25 times a. We will use this formula that is analog with this formula. Here is our figure. there are forces here too, but their moment is 0 to this axis. So we have one force, and its moment is here, m times g times distance from the axis, is equal to moment of inertia times angular acceleration. So after order we get this formula. For the instant when xg is horizontal, find the angular speed of the block. We will use change in mechanical energy is equal to 0, and kinetic energy is 1/2 times moment of inertia times angular speed squared, and the zero level of potential energy is here. So change in mechanical energy is 0. It means change in kinetic energy plus change in potential energy. Change in kinetic energy is here. Final kinetic energy minus initial kinetic energy, and plus final potential energy, it is when the center of mass is here, minus initial potential energy. This is 2 times A, so it's A, and after we express angular speed plus m times g times a multiplied by 2 divided by I and square root, we get this formula. Substitute I and reciprocal and simplify by m and a, we get the angular speed. For the instant when xg is horizontal, show that the force exerted by the table on the block has magnitude 2 times square root of 70 over 25 times m times g. So here is our figure. There are three forces, V vertical, horizontal, and m times g, and we will use this formula, horizontal and vertical. First, horizontal. This rectangle rotates, so force is equal to m times a. Radius, a is the radius times angle speed squared. This is the radius, it is here, and we substitute angular speed, it is here, and we get after when simplify by a, we get this value. After we use this formula vertical, m times g minus v is equal to m times acceleration. Acceleration is equal to now radius time angular acceleration, and we take v to the right side and this to the left side, so it is here, and we substitute alpha. We've calculated it earlier. So alpha is here. Square root of 5 times square root of 5 is 5. So 5 over 25, 1 over 5. It is here. And simplify by a. And 5 fifths minus 3 fifths is 2 fifths, m times g. And so this is this vertical force, this is horizontal force, and their net force is from Pythagoras, so h squared, it is here, 6 squared 36, and so on, plus this value squared. The common denominator is 625, so we multiply by this numerator 25, we get this, and 180 plus 100, 280, square root of 280, and m times g over 25, and this is equal to 4 times 70, and square root of 4 is 2, so we get this equation.